I would consider this to be a collection of realizations that I've had over 7 years of working on this theory. And the biggest understanding isn't just about learning what the earth is, it's about how your mind works. And I haven't seen this kind of stuff written, so I decided to write it down. And it's in this paper, I'll link it to the bottom. Experts are not always the prepared minds. A small list outlines what future discoverers will be like. It is suggested to look out for them as they think differently. This is a small list that is from the author's experience with the sharing of the discovery that planets are simply older, evolving, and dead stars. The following quote is from Louis Pasteur from a lecture at the University of Lille on December 7th, it's today, 1854. In the fields of observation, chance favors only the prepared mind. In this case, he had discovered, I believe it was something to do with fungi, I believe, I'm not too sure. Or I think he had discovered something to do with bacteria or germs. I'm not too sure which one it was. I have to remind myself of it, but it's not about that. It's about knowing that you can be prepared for something in your mind, but not really be prepared. Now, here's what I've learned. Now, somewhat true, but there is a strange paradox that needs to be explained. It is quite often assumed that prepared means educated. But this is not always the case. Being educated can block understanding. If I were to have received a first-rate education at some high-ranking university in astronomy, I would have never made the discovery that stellar evolution is planet formation. I would have done the exact reverse of preparing my mind for discovery. I would have closed it. The fact that I did not receive a university education has been my single greatest career decision. Further, a prepared mind, number one, can question assumptions. You always have to be able to question assumptions. If you assume things to be true and you never question them and you build up a whole worldview on top of those assumptions, and the assumption turns out to be false, what happens? Well, you become lost. Everything you've known just goes into the trash. Number two, can challenge peers, which is meaning they're more free of peer control and pressure, without fear of reprisal, blacklisting, or career damage, no matter how perceptibly small. A lot of scientists these days cannot challenge their peers. They have to go along with what their peers say, or else it's immediate career damage, you get blacklisted, you're not invited to speak at certain gatherings, that kind of stuff. Number three, they do not have a complete understanding of nature. That is very important. A lot of what happens to these astronomers when they go to school is they're trained that they have a nearly complete understanding of astronomical matters. But that's a very bad way of looking at things. When you look at the stars and you say, I know how those work, you're doing yourself an injustice. You have to always look at them with the eyes of, I wonder if I'm wrong about this. And you cannot have in your mind that pride of, oh, I understand how everything works. Because it makes it difficult for you to be like, oh wow, I didn't see it like that. Because your mind will always be set in a specific direction, and something really amazing can come along and you'll just completely miss it. It will go right over your head. Number four is willing to separate themselves and their minds from their own beliefs and educational conditioning. This is extremely difficult, and most scientists cannot do this. Basically what this means is you have to be able to separate your beliefs and educational conditioning from your ability to look at things in a new light. If you always pit the observations against your educational conditioning, you're always going to see things in light of your educational conditioning. And if your conditioning is false, you're never going to see what's actually there. It's always going to be skewed towards what it is you believe is true, your bias. What this means is you have to try to learn how to escape your bias. If you can't do that, you're not going to make grand discoveries. Number 5 is able to suffer criticism for thinking differently. You have to be thick-skinned. If you have a thin skin, don't make anything happen. Go with the flow, don't rock the boat, keep with the status quo, don't speak up, and always self-censor if you can't handle that, if you can't handle criticism, because great discoveries, great understanding is always going to have lots of hate attached to it from others. Number 6 has a mix of subjects understood but is not an extreme expert on any one of them. Being an expert has a tendency of becoming possibly really, really bad because of the expert claims being based on information that is supposedly basic or common knowledge. So when basic claims are false, and the expert's knowledge is based on those basic claims which are false, the entire house of cards falls. And this is another part of number 1, but I have written here. The example in my case is that astronomers claim to understand stellar evolution, yet they don't realize planets are ancient, evolved, and dead stars. This means all models taught in universities of both star evolution and planet formation are false. So what are we to make of expert opinion? It is deeply flawed and needs to be repaired. This does not mean all information is false, such as the Earth being round or the Sun being the central object to the solar system. It just means they made a huge mistake and need to adjust. And being an expert, it makes it extremely difficult to correct mistakes like that. It's impossible to make those mistakes corrected because, of the whole way it's set up. Number 7, can draw a distinction between common knowledge, which is what everybody believes is true, and what could be true. It is a scientist's mission to tease out the truth from common knowledge. It was common knowledge rocks couldn't come from outer space. Heavier than air flight was impossible. Germs did not exist. Mosquitoes did not carry disease. Humans were not related to apes, etc. Further, it is common knowledge, albeit false, that a planet is something mutually exclusive of star. So it is only a matter of time before this is corrected as well. What I have here is a basic common knowledge idea, which is false, and I'm showing why it's false. Unfortunately, a lot of the astronomers are conditioned into this common knowledge long before they ever step into graduate school and long before they ever get a degree in astronomy. Number 8, it is best to look at the prepared mind as one that is unique. Forcing all human thought to conform to standards ruins our own individual creative problem-solving skills. Think of a key that fits a specific door. You think all house keys are the same from the factory? That would be really bad. But that is how physicists train students in universities. They have to conform to standards of thought. All the keys fit the same lock. They don't want any keys to be different, yet that is exactly what they need. A different key. It is no wonder particle physicists are in their nightmare scenario, and astronomers still claim planet formation to be a mystery, even though it has already been solved. Number 9. Prepared minds deeply self-examine routinely. Without self-examination, the scientist sort of weathers away. Self-examination is needed even more in the 21st century because technology is progressing at such a rapid rate that I remember when I was taking physics at Florida State University, and my teacher told me, he's like, the information you're going to be learning in this class is probably going to be outdated. Some of it's going to be outdated by the time you graduate. And I was like, oh great, here we go. But unless you can routinely self-examine, then that truth won't ever come to being. You'll be stuck with ideas and belief systems that are out of date, and you'll be stuck trying to understand the world around you because you're not willing to self-examine. You're not really willing to actually look inside yourself and say, "Hey, is this correct?" You know, and it's essential that scientists do that. If you don't do that, then you can't really make any progress. You have to be able to weed out those crap ideas and get better ones in there. All right. Again, today is December 7th, 2018. Hopefully, this talk helps people understand the world around them better. And all right, I think that's it. Later, y'all.